Problem number 5. A 470 gram lead ball is launched at a 60 degrees angle above the horizontal with an initial speed of 100 meters per second directly toward a target on a vertical cliff wall that is 150 meters away as shown in the figure. Ignoring air friction, by what distance does the lead ball miss the target when it hits the cliff wall? Solution. This problem better to solve in the frame of reference which start to fall down with the acceleration g in the moment of shot. In this frame, target will not move and the ball will move directly to the target with a speed 100 meters, and we can count at what time it will reach this target. That will be distance over speed, which is 1.5 seconds. But the target actually is not moving. So we have to find what distance will travel our frame of reference with a movable target. That will be 1/2 gt square. This is the distance which ball miss the target. That's about 11 meters, which is answer E. Problem number 6. 3 trolley carts are free to move on a one-dimensional frictionless horizontal track. Cart A has a mass of 1.9 kilograms and an initial speed of 1.7 meters per second to the right. Cart B has a mass of 1.1 kilograms and an initial speed of 2.5 meters per second to the left. Cart C has a mass of 1.3 kilograms and is originally at rest. Collisions between carts A and B are perfectly elastic. Collisions between cart B and C are perfectly inelastic. What is the velocity of the center of mass of the system of the 3 carts after the last collision? Solution. Because this system does not affected by any external forces, there are no friction, the velocity of center of mass it's not changing. It's not affected by any amount of collisions. So we can count just velocity of center of mass before all collisions. That will be this formula, which is a total impulse multiplied by total mass, which is after all calculations, that will be about 0.11 meters per second, which is answer A. Problems 7 and 8. The following information applies to questions 7 and 8. Carts A, B and C are on a long horizontal frictionless track. The masses of the carts are m, 3m and 9m. Originally cart B is at rest at the 1 meter mark and cart C is at rest on the 2 meters mark. Cart A is originally at 0 meter mark, moving toward the cart B at a speed of v0. Question 7. Assuming that all collisions are completely inelastic, what is the final speed of cart C? Solution. Because all collisions are inelastic, finally all these 3 carts will move together and the cart C will move with the velocity of center of mass, total system. And this velocity we can find from this formula. Velocity of the third cart will be total momentum mv0 divided by total mass, which is 13m, and the answer is v0 over 13. which is A. Question 8. Assuming that all collisions are completely elastic, what is the final speed of cart C? Solution. Here we can use the standard result for in case when one cart is moving and the other is not moving is this one. As we can see from formulas, after first collision, the first car will move back and the second car will move forward with the speed v0/2. Same thing will happen during the second collision. Second car will move back and the third car will move forward with the speed v0/4. That's the solution, B, correct one.